Welcome back to Kiersti's virtual classroom. Today we are talking about human population, evolution, and biodiversity. So looking at the human population growth over time, human populations were held in check in the Middle Ages by disease, famines, and wars, and thus our population didn't grow very quickly. So it took most of human history to reach 1 billion people on this planet. But in the last 150 years, we've reached 3 billion. And in the last 12 years, we've gone from 5 to 7.8 billion people. So in the 20th century, human population has tripled, which is crazy. And it is predicted that we are going to be tripling again in the next 50 to 100 years. So looking at a world population growth over time, this is from 1700 to 2100. So as you can see, from 1700 to 1800, our population went from 600 million to 1 billion. So that's not too drastic over 100 years. But then when we look at the population in 1950 versus today, this is 2019 data, but 2021 is pretty similar, 7.8 billion. We went from 2.5 billion in 1950 to 7.8 billion in 2020. So pretty dramatic increase here. And then it is projected that by 2100 we will have 10.9 billion people on this planet. That is a lot. All right, so there are limits to growth, and there are a couple of people. We're not the first people to have questions like, what are we going to do when we have too many people on this planet? We won't have enough food supply. There will be significant overcrowding. Malthus and a guy named Marx were two kind of theorists on human population in the 1700s that looked at that human populations tend to increase exponentially when food production is plentiful. So if food production wasn't plentiful, then we wouldn't see a huge population increase. But with that said, we need to be able to sustain the people we do have and feed them. And in turn, what we do see with crop production is an overgrowth of crops, and essentially we see oversupply in the grocery store. And then once those like actual fruits and vegetables decay, we end up throwing a lot of that away. So we are already at a point to where we can supply more than what we need at the time. So that's going to come into play when we get more population in California and the United States and the rest of the world. But for now, it is good to know that we are plentiful in food production to the point at which we could probably sustain another maybe million or two in California alone. So humans inevitably outstrip food supply and eventually collapse. Human population only stabilized by positive checks, and those are not really done right now. And then humans are too lazy and immoral to voluntarily reduce birth rates. So we're all aware that infertility has been pretty big in the last 10 years or so. And more women, because they are putting off childbirth, are getting pregnant later in life. And because of that, we see more infertility issues. But because with our advancements in medicine, we are able to help women who wouldn't naturally be able to have children still have children, even though there are plenty of children who are waiting to be adopted. And things like that. So keep that kind of in mind, and we'll talk more about birth rates per woman in a few slides. All right, and then we have Karl Marx, who theorized that population growth is a symptom rather than a root cause of poverty and other social problems. So this is kind of backwards. This is saying that population growth is kind of a result of oppression and exploitation of our socially marginalized groups of people in our population. So this is saying that exploitation and oppression is causing population growth, not the other way around. So Malthus believed that population growth was a symptom of, or excuse me, was a cause of poverty and other social issues, whereas Marx is saying basically the opposite. So if we kind of look at them together, Malthus views that excess population growth is what is causing the resource depletion, pollution, overcrowding, unemployment, and thus poverty. Whereas Marx's view says that exploitation and oppression of lower class citizens is causing poverty and is causing resource depletion, pollution, overcrowding, unemployment, and thus excess population growth. So kind of two different viewpoints. Today we have neo-Malthusians and neo-Marxists. Neo-Malthusians, excuse me, believe we are approaching or have already surpassed the Earth's carrying capacity. So this says that we're at capacity, we need to stop. We should make overpopulation issues our first priority. So this would be like where you can only have a certain number of children before you're no longer allowed to have any more children. Making abortions readily available to help control populations as well. Neo-Marxists believe in eliminating oppression and poverty through social justice as the only way to solve the population problem. So here it looks at wealth and resource distribution instead of controlling the population at its source, so basically controlling birth rates and things like that. It's trying to solve social justice and eliminating oppression and poverty, and thus that will help control the population. So technology plays a huge role in all of this. Technological optimists argue that Malthus was wrong in his predictions because he failed to account for the scientific process. So current bursts of growth was stimulated by scientific and industrial revolutions. So remember, Malthus was really focused on food production, which does play a role in our population growth, but so does technology. So science and industry booms in the 1900s really significantly increased our population because we can keep people alive longer. We can give women the opportunity to have children that didn't before. One of the things that goes with that is, if you know anything about, for instance, the IVF process or in vitro fertilization process, if you are, basically what they do is they inject you with a bunch of embryos and try to see which ones stick. And if more than one sticks, you could have multiples. In most cases, if you have too many multiples, they will terminate specific pregnancies so that you only have one or two. But there was a viral TikTok video. I don't know if you guys watch TikTok. There was a viral video about a woman who did IVF, and she ended up with quadruplets, and she kept them. So this woman went from not being able to have children to now having 4 children. So that is through a scientific process, right? In the 1700s, when Malthus was theorizing all of these things, it wasn't possible for, if a woman couldn't have a child, she couldn't have a child. So modern medicine has done wonders for things like this. So keep that kind of in mind as we're talking about this. Technology does play a huge role. So can more people be beneficial to our society? Well, yes and no. More people mean larger markets, more workers, and increased efficiency due to mass productions. So we'll have a larger workforce. We can make more things, have bigger markets, things like that. That's great. And greater numbers also provide more intelligence and expertise to overcome problems. Human ingenuity and intelligence will increase. So all of those things can be more beneficial if we have more people on this planet. More people also means competition, though. So when it comes to intelligence levels, the more people we have on this planet, the harder it is to be in that elite intelligence bracket, right? Because as humans evolve, they become smarter. All right, so taking a look at human population density, we can see per square kilometer approximately how many people there are. So this chart here is the number of people per particular area. So this dark, almost black color is where we see the highest population density, and that would be in the Asia, India area. There's a little bit in Europe. In the United States, we're kind of in the middle, 25 to 75, 75 to 150 in some areas. But our population density isn't that great because we have a lot of people spread out. So if we broke this down by state, places like New York, and then in certain areas of California, you would see a much higher population density. All right, and looking at demography, this encompasses vital statistics about people such as births, deaths, distribution, and population size. The current U.S. Census estimate world population is 6.4 billion, and the estimation is our best guess right now. All right, so we have two demographic worlds. First is poor, young, and rapidly growing. This is in the less developed countries like Africa, Asia, Latin America, but they contain 80% of the world population and will account for 90% of the projected growth. Second would be wealthy, old, and most likely shrinking. That would be North America, Western Europe, and Japan. The average age here is about 40, and populations are expected to decline. So we look at population growth in Africa specifically. You will see in 1950, Africa had 0.2 billion people or so. Getting closer to 2025, we're in 2021 now. They are a little closer to 1 billion people. But by 2100, they are projected to have 4.3 billion people. Whereas North America is projected to kind of stay the same, if not decline slightly. So this is kind of an interesting viewpoint. Asia is probably the highest population as of today. They are at almost 5 billion people alone, but they are projected to peak around 2050 and then slowly decline. But Africa has a exponential growth over the next 100 years or so. So here's a kind of interesting graphic looking at projected population growth in Africa over the next, actually starting from 1950 to 2100. And this is what is projected. So you can see Asia is already fairly large, but as we get closer to 2100, Africa will kind of bubble up and Asia will shrink just slightly. So Africa will account for most of the world population by the year 2100. All right, population distribution per country. We have a couple different graphics here. This one on the left here is a pie chart. The other one is just kind of a visual based on population size. So China and India have the largest population size. Then we have the United States, Indonesia, Brazil, etc. You can read those. And over here on the left, the pie chart, Asia accounts for 57.6% of the world population as of 2019. Africa is 11%, Europe 9.7%, North America, which includes Canada, is 12.5%, South America 7.9%, and Oceania 0.7%. All right, so here are the 10 largest urban areas in the 1900 to 2019. So Tokyo was number one in 1990. And they had a population of 32.5 million. And now they're still ranked number one at 38.5 million. And then we go down to let's see, New York. So New York was number 3 in 1990. They are now number 8. So we have gone down in population. And then Buenos Aires was ranked number 10. Now they're ranked number 20, just to give you some ideas. Oh, here's Los Angeles. We were ranked number 8, and now they are ranked 18. So population has definitely decreased. All right, so scientists do not necessarily agree on the Earth's carrying capacity. So here we see two graphs that are theoretical models of food supply and population size. So here on the x-axis we have years, and on the y we have human population size. So this top graph, which is A, has no significant improvement in agriculture technology. So we're going to see a food deficit in the next 80 to 100 years based on this model. Based on the model that there is significant improvement in agricultural technology, if we have that significant innovation, we will not see a food deficit. So, dependent on technology, again, we may see a different, basically, carrying capacity of our population on Earth. All right, so I talked a little bit about demography already, which is the study of human populations and population trends. And this growth is dependent on a lot of different things. So I've alluded to a lot of these things, but we'll talk about them specifically now. So changes in population size, fertility, life expectancy, age structure, and migration. All right, so changes in population size has a lot to do with immigration and emigration. So immigration is the movement of people into a country, which we're probably all pretty familiar with. A lot of people want to come here for the American dream. And then immigration is the movement of people out of the country. So these are people that are leaving the country or they are dying. Okay, so immigration or inputs that increase the population size is immigration and births. And then outputs that decrease population would be immigration, and deaths. So that kind of dictates what our population looks like. I think with this pandemic, I know one of my colleagues, friends, has left because of the way the United States decided to treat the pandemic. And I don't blame people for leaving for those purposes, but that happens. It's not always people coming to America to be here. Some people leave because they like their country better, and that's fine. All right, other changes in population size, crude birth rate. So this is the number of births per 1,000 individuals per year. And then we have something called the crude death rate, which is the number of deaths per 1,000 individuals per year. So global population growth rate is the birth rate minus the death rate divided by 10 is the approximate growth rate in a percentage. So that is an estimation based on the number of people that should be being born versus the number of people dying every year. All right, population change. The doubling time is the number of years it takes for a population to double. For example, a population doubles every 40 years or so and begins with, let's say it begins with 25 million people. After 80 years, the population will double twice to 500 million. So in the first 40 years, the 25 million doubles, and then in the second, doubles to, I have 125 million. Well, let's just say we've got 125 million, and it doubles over 40 years to 250 million, and then that doubles again over another 40 years to 500 million. Okay, so pretend this as 125 million. All right, so population changes in size. The rule of 70 may be used to approximately calculate the doubling time in years. So doubling time would be 70 divided by the percent growth rate that you calculated previously. So this is kind of giving you an idea that how quickly the doubling time will be. All right, and then using the rule of 70, a population growing at 2% per year will be doubling approximately every 35 years. So here you would take the 70 divided by the 2%. So about every 35 years, you would see this particular population grow by double. All right, now looking at fertility. So the total fertility rate, or the TFR, is an estimate of the average number of children that each woman in a population will bear. Okay, so in the year 2000, it was approximated that, so here the human population size was 6 billion. And depending on the TFR, or the total fertility rate, you're going to see this either increase or decrease depending on the country. So certain countries will see a high TFR and certain countries will see a lower TFR. And that also has to do with their education level, the scientific, the medicines basically available to increase fertility. We also have something called replacement level fertility, which is the total fertility rate required to offset the average number of deaths in a population and for the current population size to remain stable. Okay, so like I said, fertility rates vary among cultures at different times. So in more developed countries, fertility or the total number of children per woman has decreased in the last 40 years or so. It's decreased for most of the world, but in less developing countries, they had in the 1950s, they had many more children per woman than we do see in more developed countries. But fertility rates have declined dramatically in every region of the world except for Africa in the past 50 years. And life expectancy has increased as well. So in 1900, the life expectancy for somebody living in India was 23. In the United States in 1900, it was 46 or 48. Now we see life expectancy has gone up dramatically. So in India, the life expectancy is 63, 66. It's a little bit higher now because this is a comparison in 2007 from the book. And then in the United States, the average for a female is 81. Japan is 86, right? So we've increased the life expectancy, which keeps more people on the planet longer. Okay, so lifespan is the oldest age at which a species is known to survive, and life expectancy is the average age that a newborn infant can expect to attain in any given society. So looking at fertility, again, in developed countries, we see relatively high levels of industrialization and income, and the TRF here is typically 2.1, which is 2.1 births per woman. And then in developing countries, countries with relatively low levels of industrialization and income of about $3 per person per day, TRF is usually greater than 2.1 to attain replacement level fertility. So total fertility declines as women's education increases. So this chart on the left shows female secondary school enrollment. So this is based on, these are the different countries, what level of post-secondary school enrollment they have, and what their total fertility looks like. As you can see, the more educated the woman is, the least likely she is to have a lot of children. Life expectancy is the average number of years that an infant born in a particular year in a particular country can be expected to live given the current average lifespan and death rate of the country. So I already touched on that a little bit, but here's a chart showing you what the U.S. Or what the average globally looks like for life expectancy, and the dark green is the life expectancy is higher. So global average is 68 years, U.S. average is 78, and then in some countries it is lower than 50. Infant mortality rate, or the number of deaths of children under 1 year of age per 1,000 live births. So the global rate is 49. So basically 49 babies dying per 1,000 births. And the U.S. rate is much lower. It's 6.6 per 1,000 U.S. births. And if you look at some of these lower non-developed countries, we see a lot more infant mortality rate. So in Africa, they lose a lot more infants in the first year of birth than in any other country. Looking at age structure diagrams, these are visual representations of age within a country for males and females. So in India, here's an example, the population size versus age. So most of their population is between the ages of 0 and 40. And then they have a pretty significant decline from there. So pretty pyramid kind of structure. Whereas in the United States, we see that Most of our population is actually in the 40 to 45 range. Um, and then it decreases as people age, basically. But it's a steady increase, pretty similar numbers from 0 to 45, with 45 being almost our peak. It's similar in Germany. Their highest population age is about 40. And then in China, they're pretty similar as well. This is about 35 to 40. Um, and then they have similar numbers in the from 0 to 40 bracket. All right, looking at migration. So a country may experience a change in population due to migration. The net migration rate is the difference between immigration and emigration in any given year per 1,000 people in a country. So many nations go through a demographic transition. So the theory of demographic transition suggests that a country moves from a subsistence economy to industrialization and increased affluence. It undergoes a predictable shift in population growth. So we have a transition, birth and death rates per 1,000 people over time. We see as population size increases, birth rate and death rate also decrease. So the 4 stages of demographic transition. Phase 1, there's a slow population growth because there are high birth rates and high death rates that offset each other. Phase 2, we see rapid population growth because birth rates remain high, but death rates decline due to better sanitation, clean drinking water, increased access to foods and goods, and access to healthcare. Phase 3 is a stable population growth as the economy and education system improves and people have fewer children. And then phase 4 is a declining population growth because a relatively high level of affluence and economic development encourage women to delay having children and thus don't end up having children but have high education. All right, family planning is the regulation of the number or spacing of offspring throughout the use of birth control. As more women become better educated, the TFR tends to drop. So we've already kind of touched on this. The higher the education in the woman, the less likely she is to have a lot of children. Okay, so we see purple here is no education, which are all much higher TFR rates. And the orange is less TFRs. So this is when if you have secondary or higher education, you see a decline in the number of births per particular woman. Population size and consumption interact to influence the environment. So here we have developed countries and developing countries and human population size in millions per country. So as you can see, China and India are rapidly developing, and so their population is increasing. The United States is a developed country, so their population is a lot smaller. Okay, and you'll see these other countries that are developing start to rapidly increase in their population as well. The relationship between economic development and population growth rate for developing nations looks something like this. So we have the human population size over the years. So this is 1950 to 2050. In developing countries, it stays pretty stable. Developed countries, it stays pretty stable. Other developing countries, it increases. Africa, China, and India are projected to increase significantly since 2010, basically. So our ecological footprints has an impact. So our population in a particular country increases our footprint. So we've talked a little bit about our ecological footprint in a previous module, but here we're looking at, based on our population size, what our ecological footprint might look like. So for the United States, our ecological footprint is pretty high, whereas if you look at the global average, it's 2.7 hectaacres per capita. So HA here is hectaacres. So affluence is having a lot of wealth, such as money, goods, or property. It is created by economic opportunity. And the per capita ecological footprint is a measure of the affluence. So we have a high affluence in the United States. versus, let's say, Haiti, right? So the impact, population, affluence, and technology kind of go together to make this equation, right? So we've talked about all of these things. The impact is a measure of the population, the affluence, and the technology. So to estimate the impact of human lifestyles on Earth, we can use this equation. Basically, population times affluence times technology equals the impact we will see. So again, looking at the ecological footprints, we talked about affluence, and now we're going to talk about urban populations. They have grown, and while they represent 1/2 of the world's population, they consume 3/4 of the resources. So we need to keep an eye on urban populations because they are consuming so much more of the resources than the actual population that they represent. So percentage of people living in urban areas has increased over time. In 2007, we see globally about 50% of the world living in urban areas. And by 2030, we should see 60%. In developed countries, it's a little bit higher. And then in developing countries, it's a little bit lower. So 20 of the largest urban areas in the world are listed here. This is 2007 data. I showed you a chart previously that was a little bit more updated, but this is from the book. So Tokyo has the highest population, and then we see New York, Mexico, Mumbai in India, Brazil, Delhi in India. So you'll start to see a lot of repetition here with India and China. Now we've got some high numbers in Egypt. California is on here with Los Angeles. So Los Angeles has a very high population. I'm sure you're aware if you have visited LA, they are pretty crowded down there. All right, the impact of affluence results in something called the gross domestic product, or the GDP, which you probably have heard of in passing, or maybe you know a little bit more about this than the value of all products and services produced in a year in that country is the GDP. Okay, so I'll say that again. The value of all products and services produced in a year in that country is the GDP for that country. So the GDP is made up of consumer spending, investments, government spending, and exports minus the imports. And countries' GDP often correlates with its pollution levels. Okay, so sustainable development is a common, if elusive, goal. So our goal with most of these environmental impacts, human population, a big one, is that we want to have sustainability. So economic development has had a strong influence on society's impact on the environment. So the better our economy is, the more population growth we see, which will impact our environment more. So sustainable development is this common goal, right? So ecosystem it needs to be stable, and it will be threatened if global consumption patterns continue. So if we continue our patterns and increase our population to 10.9 billion by 2100, it's the environment that will suffer. While alterations to ecosystems can improve human welfare by bringing clean drinking water and food to people, the same changes make poverty worse for others. So sustainable development is our ultimate goal, and if we can improve sustainability, the standard of living may improve for a large number of people. Okay, so human population growth, it needs to kind of taper out, in my opinion. We need to kind of keep it at a sustainable level and not a significant growth level, because our planet cannot handle too much more impact unless we all change all of our habits to be very environmentally friendly. We need to help create a more sustainable Earth. All right, and that's it for this presentation. I will see you guys in the next one. Bye.